Alright, so for the last example of 2.5b, we're going to find second derivative. So before we can find the second derivative, we have to find first derivative. So we're going to take derivative of this function, which 2x dx over dx plus 2y dy over dx equal to 0. Alright, so just to remind you, in order for us to find dy, the first derivative is the one that we have to solve for dy over dx, right? So the first one, the dx over dx mean 1, so I can cancel that out. I don't have to use it. So I can minus 2x on both sides, and I have 2y dy over dx equal to negative 2x. Okay, now to solve for dy over dx, I'm just simply divide by 2y. Okay, so this cancel out, so I will have dy over dx equal to, alright, let's look on this side. I see that the 2 also cancel out, so what I have is negative x over y. So this is what we call the first derivative, right? But the problem, this example is asking you, if we go back, is asking for the second derivative. So that means I'm going to take derivative of this function again. So to do that, if you look at this one, if you recognize in order for you to take derivative again, pay attention to the notation. That means I'm taking derivative again. So the notation is give the 2. Also over dx squared. So this notation means second derivative. If we look at this one right here, you recognize this is quotient. So I'm going to use a quotient rule to take derivative of this one. So that means y squared. I'm taking derivative of the first one, which is going to be negative 1, times g of x, which is y, minus negative x, times derivative of y, which is 1 dy over dx. Alright, so let's rewrite this one. So we have y squared negative y minus a negative become positive x dy over dx. So the problem with this one is we're not done for one reason, is that the dy over dx. You cannot leave that on this side of the problem. So we have to do one more steps. Okay, which is, let's go to the next page. So let's recall the second derivative that we have is negative y plus x dy over dx over y squared. And we want to cancel out, we're going to do something so that dy over dx is going to disappear. So let's recall the first derivative that we solved, which is negative x over y. So now instead of, this is the first derivative that we solve for before we take in the second derivative. So what we can do is that we can replace dy dx with negative x over y, because that's the same thing. So negative y plus x times negative x over y squared. Okay, so let's simplify this one. So negative y minus x squared over y over y. Okay, keep in mind when you divide, this is the same as y over 1. So this is same negative y minus x squared over y times 1 over y, right? So I can distribute, when I multiply this in, negative y over y minus x squared y over y. Okay, so let's see. Negative y over y gives you negative 1. The y cancel out, so minus x squared. So this is the second derivative. Let me rewrite the second power. So this is the second derivative. Okay, so let's talk about steps for taking second derivative. Step 1, take first derivative. So first step, first you have to take first derivative, of course, right? In order for you to get the second derivative, you have to take the first one. Then, depend on the function given to you, then you can determine what rules that you have to use. It can be products, it can be quotients, it can be a trig function that you have to take derivative again. So secondly, you're going to take derivative again. Take derivative one more time. Take derivative one more time. Okay. Then this is the important part after we take this. The second derivative is that we want to simplify the function. We want to simplify the second derivative. So to indicate second derivative, you can do double prime. And step 4, substitute the dy over dx. Okay. Actually, I make a mistake right here. We should have step 3 and 4 switch. That's my... Okay, so step 3, I'm going to rewrite this. I'm going to erase this. Okay. Step 4 is the one that you're going to simplify. Step 3 is the one that you're going to substitute in the dy over dx. Then you simplify. So simplify should be the last step. So I'm going to erase this right here. Sorry about that. So after you take the second derivative, you would substitute in the dy over dx, which is the first derivative that you solve for. Then you can simplify the function, which is double prime of x. Okay? And that is it for second derivative. It's the same idea as the other function. Second derivative means you take in derivative the second times. The only difference for this problem is that you end up substituting the dy over dx into the second derivative and then simplify. So it's more work, but the same idea. Alright, thank you for listening, and again I apologize for the mistake that I make on the steps. But hopefully this helped. If you have any questions, do see Miss Conant or me. I will have office hour on Thursday, and I know Miss Conant have office hour on Friday. See you then.